We want to introduce you to the study the usage of stochastic matrices while learning the topic, Eigenvalues and Eigenvectors of a matrix. In the course of higher mathematics, the study of linear algebra is provided in the course of higher mathematics at the university. Matrices, their determinants, solving a system of linear equations, and modeling using them are considered while learning the course. Several hours are also devoted to the consideration of eigenvalues and eigenvectors. However, the practical application of these concepts is almost not traced, and therefore the importance of learning them remains unclear to students. Mathematical modeling using eigenvalues and eigenvectors based on the usage of stochastic models is also neglected. From the different studies, it can be seen that Markov chains have a fairly wide application in various spheres of life, so they require further research, which we consider based on eigenvalues. Markov random processes, in particular Markov chains, as a mathematical model, are used to study processes in many branches of science, in particular in economics, ecology, sociology, technology, and industry. Eigenvectors. Having chosen the topic, Eigenvalues and Eigenvectors of the matrix, it compiled a system of problems for students of various specialties. Systematized problems were aimed at developing certain skills. The separation of these skills can be demonstrated using the following problem. Two companies, X and Y, provide telephone, internet, and digital television and share a market of 5 million people. Company X is not very customer-friendly and loses 12% of its customers to Company Y every year. Not all of Company Y's customers are satisfied with their service, and every year 3% of Company Y's customers switch to Company X. We want to investigate how the number of customers of both companies will change from sometimes. To sum up, the skills needed to solve the problem: the student knows what discrete time Markov chains are and how they are formed. The student knows how to enter notation and create a system of equations that reflects the process described in the problem. The student is able to rewrite the system of linear equations in matrix form. The student knows how to recognize stochastic matrices, define them formally, and knows which definitions and theorems of the topic, eigenvalues and eigenvectors of a matrix, work with them. The student knows how to find the eigenvalues of the matrix. The student knows the theorem on the presence of stochastic vectors of the stochastic matrix and knows how to work with it. Theorem: if one takes m element of Rn x n as a stochastic matrix, where J is greater than or equal to 0 for all I, j element of 1, n, then there exists a unique stochastic vector V** operator which is the corresponding eigenvector to the eigenvalue 1. Eigenvalues lambda of the matrix M other than 1 satisfy lambda less than 1. For all stochastic vectors V1 has lim right pointing arrow infinity sign MNV equals V** operator. The student has the skills to analyze the results obtained as a result of solving the model and coming to conclusions after distinguishing the system of skills. It was expected to develop not only skills directly related to the mastery of the topic but also skills. This development will help to understand where the calculations of eigenvectors and eigenvalues of the matrix can be used. So, the study aimed to develop a system of problems for learning the topic, Eigenvalues and Eigenvectors of a matrix, to students of different university specialties. With the help of systematized problems, show students the usage of eigenvectors and eigenvalues in various branches of science and spheres of life. To conduct an experiment in which students of different university specialties will take part, to check the impact of the developed system of problems on the development of students' skills. The research method was the systematization of problems to show students the usage of eigenvectors and eigenvalues in various fields of science and spheres of life. Before developing the problems, several related theoretical propositions were identified, which became the basis for their systematization and solution. Definition of stochastic matrix and stochastic vector. The theorem on the product of a stochastic vector by a stochastic matrix. Definition of Markov chain. The theorem on the presence of one among the eigenvalues of the stochastic matrix. The theorem on the presence of stochastic vectors in a stochastic matrix. The theorem on the presence of stochastic vectors in a stochastic matrix has become the main one while systematizing and solving problems. It is considered the system of problems that will allow students of different university specialties to demonstrate the application of eigenvalues and eigenvectors of the matrix in practice. It has been systematized the problems for the code specialties management, marketing, entrepreneurship, trade and exchange activity, mathematics, statistics, applied mathematics, secondary education, mathematics, biology, horticulture and viticulture, horticulture, ecology, earth sciences, agronomy, earth sciences, power engineering, electrical engineering, and electromechanics, transport technologies. International economic relations to check the effectiveness of using the system of problems in which stochastic models are used in classes of linear algebra. An experiment was conducted. The base for experimenting was universities. National University of Kyiv Mohyla Academy, and Kryvyi Rih State Pedagogical University, and students of majors, management, marketing, entrepreneurship, trade and exchange activity, applied mathematics, secondary education, mathematics. The main tasks of the experiment were the study of learning, eigenvalues and eigenvectors of a matrix, by students of different majors, developing and implementing the system of problems that can demonstrate the usage of eigenvectors and eigenvalues of the matrix while constructing stochastic models, analysis of the experiment's results. The control group and the experimental group were formed at the beginning of the experiment to determine the level of students' mathematical preparation after testing the first few topics of the linear algebra section in the higher mathematics course. After the end of the experiment, students were tested again. At the beginning and the end of the experiment, students of the control and experimental groups solved the same system of problems developed by the authors of this study. The experiment lasted 2 weeks, during which the eigenvalues and eigenvectors of the matrix were studied in the course of the considered section of higher mathematics. 125 students took part in the experiment, of which 64 students were included in the control group and 61 students in the experimental group. The test, which was offered to students at the final stage of the experiment, contained 3 types of problems. The first type of problem is aimed at working out the steps of calculating the eigenvalues and eigenvectors of the matrix, namely, solving the equations given in the form of determinants and finding the fundamental system of solutions of an indeterminate homogeneous system of linear equations. This type of problem tests the skill to rewrite a system of linear equations in matrix form, skill 1. The second type of problem is to find eigenvectors and eigenvalues of matrices of different order. These problems are aimed at testing students' skills to calculate eigenvectors and eigenvalues of a matrix, skill 2. The third type of problem includes tasks on the application of eigenvectors and eigenvalues of the matrix, namely, finding the canonical equation of the second-order line, as well as tasks on developing a linear exchange model, international trade model. This type of problem was given to test the skill to build mathematical models for a problem, as well as the skill to adapt the obtained results following the condition of the problem and the ability to come to a specific conclusion, skill 3. It is presented in the table and the diagram the percentage of correctly completed problems of the first, second, and third types. It is clear from the table and diagram that the percentage of skills 1, 2, and 3 in the experimental group is higher than in the control group. For the first skill 7.4%, for the second skill, by 16.4%, and for the third skill, by 24%. It confirms the effectiveness of the problem system that was developed, in which modeling on stochastic models is considered using eigenvalues and eigenvectors of the matrix. Setting the conditions of the problems was carried out based on observing the stages of their solution to the conclusions of the theorem on the existence of stochastic vectors of the stochastic matrix. Therefore, the theorem became a formula for the systematization of problems with which the students of the experimental group worked. Of course, the students of the same group were also familiarized with all the theoretical provisions that ensure the modeling and solving obtained formalized models. The results of the experiment confirmed the expediency of using the developed problem system for learning the topic, eigenvalues and eigenvectors of the matrix. It has been come up to the conclusion stochastic matrices have wide application in various scientific fields: data analysis, probability theory, statistics, mathematics, computer science, and population genetics, and life practice, migration, employment, changes in urban systems and landscape, etc. Therefore, using matrices of this type can be demonstrated to students of different university specialties, provided students consider stochastic matrices, which are also called probability matrices, Markov matrices, or substitution matrices. Additional concepts and theorems should be presented to students while studying the topic, eigenvalues and eigenvectors of a matrix. Among them, the definition of a stochastic matrix and a stochastic vector, the theorem on the product of a stochastic vector by a stochastic matrix, the definition of Markov chains, the theorem on the presence of one among the eigenvalues of a stochastic matrix, the theorem on the presence of stochastic vectors in a stochastic matrix, The theorem on the presence of stochastic vectors in a stochastic matrix can be used as a basis for the systematization of problems that present applications of eigenvalues and eigenvectors of a matrix in real-life situations. This is explained by the fact that the stages of solving such problems must be carried out by observing the conditions and conclusions of this theorem. The usage of the developed system of problems and presentation of the theoretical foundations of its involvement while studying the topic, eigenvalues and eigenvectors of the matrix, does not require a significant increase in hours. The results of the experiment show that students who work with the recommended system of problems demonstrate better results, which cause to the improvement of skills ensuring mastery of the topic. Very thanks for your attention.